Beavers are quietly transforming landscapes across the Rockies and Great Plains, but their impact is far more profound than most people realize. These industrious creatures build dams that interrupt narrow streams, slowing the flow of water and creating a series of ponds that reshape entire valleys. These mud and stick structures don't just hold back water, they foster thriving habitats for willows and cottonwoods, maintain lush green corridors long after the surrounding hills have dried out, and help mitigate the destructive power of floods. But here's where it gets controversial. While beaver ponds offer undeniable ecological benefits, they can also cause conflicts with human land use, raising important questions about how we manage these natural engineers. In the western United States, where droughts are becoming more persistent and wildfires more frequent, these ponds act as natural reservoirs and safe havens when streams run low. This has inspired efforts to bring beavers back to river systems and to replicate their dam building with human-made structures called beaver dam analogs, BDAs. However, a major challenge has been predicting which locations will support expansive wetlands and which will only produce small pools. Until now, land managers lacked reliable tools to forecast the size and water-holding capacity of these ponds. A groundbreaking study published in Communications Earth Environment, https://articles/s43247-02573x, offers new insights. By combining high-resolution aerial images with machine learning techniques, researchers mapped over 1,200 beaver ponds across Colorado, Wyoming, Montana, and Oregon. Their goal was to identify the key factors that determine pond size. The standout predictor was dam length. Longer dams consistently held back more water. This was followed by the height of nearby woody vegetation and the strength of downstream water flow. Together, these three factors explained nearly 75% of the variation in pond size. This finding confirms what ecologists have long suspected but never quantified on such a large scale. The longer the dam, the larger the pond. Establishing this clear relationship equips restoration practitioners with a powerful tool to estimate pond size before building dams or BDAs. By analyzing the dams people construct, we can estimate the area of the pond behind them, explained Luan Wan, the study's lead author and a postdoctoral researcher at Stanford University. This allows us to better understand how much water can be stored and the resulting hydrological and ecological impacts. While the study relied on summer imagery, which might have missed some ponds obscured by vegetation or affected by seasonal water changes, and used relatively coarse climate data, the statistical relationships held strong across different ecological regions. This highlights the dominant role of dam shape and local stream conditions over broader climate factors. Any progress in understanding where, when, and how beavers build dams, and how large those dams will be, is incredibly valuable, said Jesse Moravec, a postdoctoral researcher at the University of Minnesota's St. Anthony Falls Laboratory who was not involved in the study. This knowledge is especially crucial for beaver restoration and reintroduction projects, helping us identify the right local conditions to maximize their positive impact. For beavers, building dams is a survival strategy. Larger ponds protect them from predators and provide safer routes between food sources. Deeper water also insulates their lodges from freezing during harsh winters. But the ecological effects extend far beyond individual beaver colonies. Pond size influences how much water is stored in the landscape, how far floodwaters spread, and how much habitat is created for plants and wildlife. A beaver dam is essentially built to store water and give the beaver a bigger backyard, said Cherie Westbrook, a professor of eco-hydrology at the University of Saskatchewan and associate director of the school's Center for Hydrology, who was not part of the study. By storing more water in the landscape, You're naturally protecting against drought and reducing wildfire spread. Until recently, most tools available to land managers focused on estimating the number of dams a stream could support, rather than the volume of water those dams could hold. Yet, the installation of BDAs is rapidly increasing across many regions, sometimes outpacing scientific guidance. There's a surge in BDA projects, but we still lack clear scientific advice on how many are needed, where they work best, and why, Westbrook noted. This study directly addresses those questions by pinpointing where and why BDAs and natural dams can effectively produce desired hydrological outcomes. The research also compared the influence of climate factors like precipitation and temperature against local physical features such as valley shape, stream power, and vegetation. Surprisingly, climate variables were weaker predictors of pond size. Juan suggested this might be due to the mismatch between the coarse climate data and the fine-scale nature of beaver ponds. The data resolution was a limitation, but I've long believed and observed that geomorphology matters more than climate, Westbrook said. There's only so much physical space that can be flooded by beaver dams, and beavers can only build dams so large. This adaptability to different climates is evident in beavers' wide range, from Canada's boreal forests to the arid deserts of the Southwest. Beavers are incredibly adaptable, Moravec said. As climate change progresses, we hope they'll continue to adjust and keep providing their ecosystem engineering benefits. While beavers are not immune to climate pressures, they often survive droughts, floods, and fires by creating refuges that shelter their colonies and other species. That's what makes them a powerful keystone species, Moravec emphasized. This story is made possible by readers like you. Our nonprofit newsroom delivers award-winning climate journalism free of charge and without advertising. We depend on donations from readers to continue this vital work. Please consider supporting us. Donate now. InsideClimate.fundjournalism.org/donate with number 15, campaign 7013A0003BK97AC. However, the very ponds that provide these benefits can also lead to conflicts. They may flood farmland, damage culverts, or topple trees valued by landowners. It's crucial to acknowledge the risks, Westbrook said. The challenges of using beavers as a nature-based solution are often under-discussed, but are just as important as the benefits. The effects of beaver ponds vary widely by region and can sometimes contradict climate goals. For example, in Alaska's Arctic, expanding beaver ponds have been linked to accelerated permafrost thaw, releasing greenhouse gases and threatening fish populations vital to indigenous subsistence traditions. InsideClimateNews.org/news/310122/Beavers Alaska. This highlights how beavers can, in some cases, exacerbate climate risks. Predictive models like the one developed in this study can help land managers anticipate how much land a dam might flood, reducing potential damage to property and livelihoods. Moravec noted that more accurate predictions of pond size and flooding potential increase the chances of success in restoration projects. One of the study's most unexpected findings was the consistent geometric relationship between dam length and pond size across diverse regions. Juan admitted she hadn't anticipated such a clear pattern, which could now serve as a straightforward, data-driven method to estimate pond area during project planning. State agencies are beginning to incorporate beaver management into broader water and habitat strategies. In California, wildlife officials have reintroduced beavers onto tribal lands, while in Colorado, restoration efforts increasingly consider where beavers are most likely to thrive. By quantifying how local stream conditions influence pond size, this study offers a valuable framework for making these decisions more strategic and effective. Looking ahead, researchers aim to explore how long ponds last before failing, how much groundwater they store, and how networks of ponds evolve over time. Juan hopes to expand the mapping project using artificial intelligence. Westbrook highlighted the importance of studying dam life cycles, including construction, collapse, abandonment, and renewal, as an exciting frontier. Moravec pointed out that understanding subsurface water storage remains a significant challenge. Across all these efforts, there is a shared recognition of beavers' remarkable adaptability and the resilience they bring to the ecosystems they inhabit. Beavers are vital partners in adapting to a changing climate in North America and Europe, Moravec said. The more we learn to work with them effectively, the better off our landscapes and communities will be. About this story, you might have noticed, this story, like all our reporting, is free to read. Inside Climate News is a 501c3 non-profit organization. We don't charge subscription fees, hide our news behind paywalls, or clutter our site with ads. Our mission is to make climate and environmental news accessible to everyone. We also share our reporting freely with many other media outlets nationwide, many of which lack the resources to produce their own environmental journalism. With bureaus coast to coast, we cover local stories, collaborate with newsrooms, and co-publish articles to ensure this critical information reaches as many people as possible. Founded in 2007 by two journalists, Inside Climate News won a Pulitzer Prize for national reporting 6 years later, and is now the oldest and largest dedicated climate newsroom in the U.S. We tell complex stories, hold polluters accountable, expose environmental injustices, debunk misinformation, scrutinize solutions, and inspire action. Every aspect of our work is funded by donations from readers like you. If you haven't already, please consider supporting our ongoing efforts to report on the most urgent crisis facing our planet and help us reach even more readers. Please take a moment to make a tax-deductible donation. Every contribution makes a difference. Thank you.